Hello, welcome to the TechnoVersions shop. My name is Brian, and today I'd like to tell you a little bit more about our TachMatch product, which is designed to make your tachometers work. Typically, TachMatch is necessary when you've done an ignition change. Maybe you've changed your engine from a V4 to a V8, different number of cylinders. Maybe you're trying to incorporate an old vintage tach. Just when things don't work together, the TachMatch's job is to make them work together. So it deals with several different types of tachometers on the output and several different types of triggering on the input. And the goal of the TachMatch is to put those things reconfigured so that the input works together with the output that you've got. So for the basic different types of output we've got, there's several different types of tachometers. The most common one is a voltage-driven one like this and this, and they are typically connected from the negative terminal of your coil directly into the back of the tachometer. Another type of tachometer is the current-driven, and that would be one typically like you find in old Datsuns and the Smiths RVI tachometers, early Fords and Shelbys. And these are identified because they have a loop on the back. And so the current going through the wire induces a signal into the tachometer through that loop, and that's how it works. So these are typically connected between the ignition switch and the plus voltage, the plus terminal of the coil. The final type of tachometer that we deal with, we call the vintage tachometers, and that would be the old Sun and Stewart-Warner units like this that only have two terminals on the back, a plus and a minus, and they were originally driven with an interface box such as this EB series. The Stewart-Warners had a little bit different interface. It was round. And the TachMatch can be used to replace this interface box and directly control it, or it can be mounted inside. There's instructions on our website about how to mount the TachMatch in there and connect to these terminals so that it looks like the original installation. So that's the output side. On the input side of things, the TachMatch can accommodate points and coil input, HEI, MSD, Pertronics, ECU, a variety. So it's got several different types of inputs, several different types of outputs, and you configure it to match your environment to make your tachometer work. So we have several products in the TachMatch line. The basic one is the TachMatch TM03, and that's the one, the standard unit that will control voltage control tachometers and the vintage tachometers. It's also available in a slightly different version, the same module, but including a shunt that allows it to be configured to drive the current-driven tachometers like that. And finally, in our product line, in the tachometers, we have a V-boost module, and we have this because some voltage-driven tachometers require a stronger signal than the 12 volt that's generally generated by MSD and us and ECUs. They require a strong voltage spike that's inductively created by the coil. So this module, via a big inductor inside, allows you to put that spike back on and make that type of tachometer work. And the main one that we always need these on is VDO, but there's a lot of other ones, especially as tachs become degraded a little bit through the years. Since some of the older Datsun tachs, for example, might or might not need that. But anyway, that's available as part of our product line as well. Today we're going to be using our tachometer tester to provide voltage for this. It has an internal battery, and also to provide a signal. So that's the family. We have a wiring kit available if you want to purchase that, which has some wires of the appropriate size. So let's get started and let's configure our tachometer, or our TachMatch. So typically when you get it, you need to remove a screw out of the back and open it up. And it looks like this inside. There's a terminal strip along one side, and the wiring goes into that. Again, we use number 18 wiring, but you can use a little bit larger or smaller wiring and it'll work fine. Other than if you're doing current driven tachs, then you probably want to be with at least 18. But anyway, into the first terminal strip, we have plus 12 volt switch from the ignition switch. It uses very little current. The next wire is ground. The next one is the output to the tachometer. And the next one is the trigger input. And this would be the input for HEI or coil. And there's another input that you can alternatively use that's used with an ECU or possibly a 12 volt input, but none with spikes. Otherwise, in this unit, we have an LED up here that it's blinking, tells us we use during programming and troubleshooting. We have a potentiometer here that is used to calibrate the vintage tachometers to adjust those to work properly. We have a terminal strip here that allows a jumper to be placed on 3 positions. The norm one in the middle is used for voltage driven tachometers. The top one is used for the vintage tachometers, and the bottom one is used for the current driven tachometers. And finally, inside the unit, we have 3 buttons that are used for programming the unit and to generate a calibration signal. So let's use this unit and drive a tachometer with it. So the configuration is done with these buttons, and we tell the unit how many cylinders that the engine has with this button. We tell it how many cylinders the tach was designed for with this button, and this to generate a calibrate signal. So we tell the number of cylinders that the engine has by pushing this and counting the pulses here on the LED. Oops, turn power on first here. 1, 2, 3, 4, 5, 6, 7, 8. Try that again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we set up for an 8-cylinder engine. And then this is the tachometer. Let's see what that's set for. 1, 2, 3, 4. Okay, for a 4-cylinder tachometer. So that's what we have. Here we have a 4-cylinder tachometer. It's voltage driven, so we have the normal input. So as you can see, we've got our tachometer calibrator set to 3000 RPM here, and that's what's being displayed on the tachometer. So we know we have the right setting there. But if that wasn't the case, we would push this calibrate button here, and it generates a 4000 RPM signal, so we can make sure that our tach is set with the right number of cylinders and our output wiring is correct. So this tachometer, you can see we can drive it to any RPM we want because we have the correct settings for that. So next, we'll change to a different tachometer here. We'll change to this one, which is designed for an 8-cylinder. And so I'll show you how to change these settings. So here we count 1, 2, 3, 4, 4. So each time, pressing and holding that, and then press this button, it'll increment. There's 5, 3, 4, 5, 6, 7, 8. Okay, so now you can see that we have the calibrator set for 3000 RPM and our tachometer reads 3000 RPM, which is correct. We push the calibrate button and it goes to 4000 RPM. So we know that our output is correct and that it's working properly. Okay, let's take a look at a vintage tachometer, and we have several settings that we need to change on this. So we're going to turn power off, and I'm going to put the output into the input jack of our vintage tachometer. This would be the same as the plus terminal, and the ground terminal is connected to ground. Okay, so to configure this for a vintage tach, we need to change the jumper here up to the top to vintage tach. And then we need to change the tach cylinders to 9. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so with that set to 9 and this on the top, we have it configured properly for a vintage tachometer like this. So when you start, you should set this potentiometer down to the bottom, just so it doesn't give too strong of a signal to start out with. Then press and hold the calibrate button, and you can see on the tachometer here how it went up. So we set the calibration adjustment until it reads 4,000 RPM. Okay, and that's the calibration for it. And now let's try it and see how it works with our tach calibrator here. This is 3,000, 4, 5, 6. So you can see it works properly now through the range. This is a particularly nice tach, and this should be 500 RPM. So that's how we drive a vintage tachometer. And some of them are not very linear and they're a little bit sluggish, so you might want to adjust them at like a lower RPM, and it might work out better in your application. So the final type of tachometer that we're going to test here is the current-driven tachometer. And this one is from a 240Z Datsun. And when we're connecting up to these, we need to make sure that the shunt is installed in the input. There we go. Okay. And we change the jumper down to the bottom where it says iDrive. And then we need to set the number of cylinders. I should point out one thing here. Now, we have an input signal as though the engine is running. But let me disconnect that, and you'll see that the LED comes on. So the LED is on when the engine isn't giving it a trigger. And that can affect, you need to ignore the fact that it comes back on when you're counting. So for example, here, if we count these, it'll be 9 the first time. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the pause and it comes back on. Don't count that last one where there's a pause and it comes back on. Okay, so now we need to change this one to 6, and it's currently 9. So you can, again, hold this down. You need to wait. There's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so now we have it set for an 8-cylinder input, a 6-cylinder output, and a current drive. So let's push the calibrate button. And there you see we have 4,000 RPM. So we know that we're connected properly. We'll provide a signal to it. 4, 5. So you can see that this tachometer works fine, this current-driven tachometer. Okay, as far as adjustment goes, the computer inside the TachMatch makes a very, very accurate division or multiplication of the frequency it's getting. So it's accurate to just, it's almost perfect. And so if there's any error on a normal voltage or current-driven tachometer, it would be within the tachometer itself. But you can calibrate it to a certain extent if you want. In order to do that, you hold down the calibrate button, and then you can use these two buttons to move the tachometer reading up and down. See how this one is moving it down and this one is moving it up. And then when you release the button, it will save that. And so it has that correction factor from now on for that tachometer, and it'll scale it appropriately. You can look at these devices as being something that takes a digital input and a digital output, and you can have any ratio you want between 1:8 and 8:1. And so people have done some interesting things using this as a frequency conversion too. Let's see. Okay, as far as troubleshooting, if it doesn't work, okay, the first thing is these are completely separate, the input and the output, only connected together by the computer. But when you push the calibrate button and your tachometer doesn't read 4,000 RPM, that means that there's something wrong in the wiring between the tachometer or the compatibility or some issue on the output side of things. If the LED does not go out while the engine is running, that means that you have a triggering issue. The LED turns off every time there's a pulse. And at real low RPM, you might even see just a little bit of pulsation there. But basically, it should go out while the engine's running. And that's an indication that you have the input trigger connected properly. One last thing, if you accidentally put the jumper on vintage mode and it's not a vintage tach, it may read, if you have an 8-cylinder tach, it might read 4,000 RPM, and a 4-cylinder tach, it might read 8,000 RPM, and that's just an artifact of the type of stimulus that we use. But anyway, that's an indication if you see that you may have the jumper on the wrong position. Anyway, thank you for going through all of this with me. I hope it helps. I'm sorry for kind of the maze of wires here, but some of these are test fixtures that we use. We build the product right here, and we test each TachMatch with each type of tachometer before it goes out the door to make sure it's going to work right. Anyway, if you have any questions about any of this, give us a call. We have this information on the website, and the instruction manual is also on the website. Thank you for coming.